video, we're going to be looking at the linear oscillatory motion experiment. In the linear oscillatory motion experiment, you're going to measure the spring constant of a spring using two different methods. First of all, you're going to be using a direct method. For the direct method, you're going to be making use of Hooke's law, which said that the force is equal to the spring constant times the displacement. And there's a negative sign here to show that the force, that's the restoring force, and the displacement are in opposite directions. So you're going to be having a spring, you're going to be adding more and more mass to your spring and seeing how the displacement of the spring changes as you add more mass. The mass provides a weight force, and so when the weight force is in equilibrium with the restoring force, the spring will be stationary. You're then going to measure the spring constant of the spring using an indirect method. For the indirect method, you're going to be making use of simple harmonic motion. You're going to be pulling the spring down a little bit and measuring the period of the oscillations. You're then going to be making use of the equation that the acceleration is equal to minus omega squared x, where x is the displacement, and omega is given by the square root of k on m. At the end of the experiment, you're going to be comparing the results that you get from these two different methods. So this experiment's got two parts. First of all, you need to measure the spring constant using the direct method and this equation, and then you need to measure the spring constant of the spring using the indirect method, where you'll be measuring the acceleration. For the indirect method, you'll need to start your masses oscillating in simple harmonic motion. To do this, move them down a very small amount. Don't pull them down a large distance because this can cause the masses to fall off the end. It also gives you incorrect results. You'll be using a motion sensor to measure the displacement, the velocity, and the acceleration of these masses. So the motion sensor is attached to the Logger Pro and then into the computer. To collect data for this, you need to open up the Collisions and Car Crash Part 1 template on the computer. When you open up this template, you'll have three graphs: a position graph, a velocity graph, and an acceleration graph. You can then collect data about how the end of the spring is moving. You should end up with some nice curves like this for the position, velocity, and acceleration. It's then your task to come up with a method of using this data to calculate the spring constant for the spring.